Hey, this is Alpha. Today I want to talk about RAG or Retrieval-Augmented Generation. If you are in a space and you want to use AI agents to help you automate workflows, you probably have heard the word RAG. If you haven't, I'll give you the rundown on what it is, how it works, and what are some of the limitations and what are some of the ways to overcome them. But I want to start this discussion with an announcement that the Anthropic team did back in September of this year. They introduced what they called contextual RAG or contextual retrieval, and I'll tell you what that is in a moment. But this is an important milestone for the community in that RAG, ever since it came out many years back, has evolved, and this is just one representation of that evolution. So contextual retrieval is a method that was released by the Anthropic team, and the goal really is to help developers create better RAG systems. So you can see that developers typically use what is known as a knowledge base to empower AI agents with both internal and external data, and the process of fetching data from these sources is called a RAG. Beyond the concept itself, the company introduces contextual RAG, which is a combination of two things that aim to overcome the limitations of traditional RAG. First is contextual embeddings, and this is a process where you are creating embeddings that are contextualized to the content that you store, and I'll explain what that means later on. And the second is Contextual BM25, Best Match 25. So this is a ranking algorithm that returns the top 25 results based on semantic meaning. And in this case, it's a contextual technique that simply aims to ground the responses. And I'll, of course, tell you what that is as well. So what happens when you combine these methods together? You create a contextual RAG, and the impact is actually quite substantial. And before I dive into the benefits here, really, I want to emphasize that RAG has many limitations, one of which is hallucination. If the knowledge base is not properly created, if it's not properly updated or managed over time, what can happen is when an agent is pulling data from that knowledge base, it can hallucinate on the response or the answer. Now, the Anthropic team recognized this, as did the rest of the community, and Anthropic team aimed to solve it with contextual retrieval. And the result is that you have a approximate 50% reduction in failed retrievals, means retrievals that could not respond according to a query. And of course, when you combine it with a re-ranking or a sorting algorithm, you increase the failure, you decrease the failure rate even more, meaning increase the accuracy. So what is the things that they mention on their blog post? Of course, there's ways to assist with RAG or retrieval of information, and they give a few examples here. If you increase the input token context window of a large language model, that just means that you don't need a RAG, and I'll come back to this in the future when I conclude this video. And the second is prompt caching, which just means reusing prompts in a way that saves on token costs. And the process as they break down here of a traditional RAG is nothing more than breaking up information into small chunks of text, storing them on the knowledge base, which is sometimes called the corpus of docs, creating a text embedding using an embedding model. That could mean OpenAI embedding model, or can be open source or any other model, converting chunks of text into vector representations as vectorized embeddings, essentially zeros and ones, and then storing those embeddings into a vector store or vector database. This is not the same as a traditional database, but it is an evolution of how you can store vector data or matrix data on a database. That's the third and final piece here of a traditional RAG. So when you have user asking for a question, the vector database is used to find the most relevant chunk, and then once you've stored the chunks, you're then sending the most relevant chunks along with the query back to the AI, and that's what generates the user's response. If we scroll down here, we see that Anthropic team describes BM25 as well, which is the ranking or sorting mechanism, and they explain basically the standard RAG in this nice to have, I would say, flowchart, where you have what they call standard RAG system. It uses both embeddings and the best match re-ranking algorithm. So you have a pre-processing step of embedding and re-ranking. You store that, of course, in a vector database, and at runtime, the user is asking a question. If the question is relevant to a knowledge base, you do a retrieval, and then you rank the results and you push the results along with the response, thanks to an AI model like Claude or OpenAI, back to the user. If I scroll down here, the question that can be asked by the user is, what is the revenue growth for a company for a specific quarter? And of course, when you have a retrieval, you may find a relevant piece that could be along the lines of, the company's revenue grew by 3% over the previous quarter. This just means that the chunk is relevant enough that a large language model may be able to answer the previous question. And the Anthropic team makes a note here that the chunk by itself, meaning the chunk of text that was retrieved, does not specify which company it's referring to or the relevant time period, which makes it very difficult to retrieve the right information or use the information effectively. This is the two big challenges of using traditional RAG. Do you have the most relevant information, and do you have the information that will effectively answer your question? And this is where hallucinations occur. User asks a question, you have some retrieval, but it's not relevant or it's not effective enough in the response, and then you get back a poor response or a hallucinated response. Contextual retrieval is a way to overcome this. Of course, this is what Anthropic has done through their effort, and so they're quite public about what they're showing here in terms of the strategy, the method, the architecture, as well as the open source code. They do have cookbooks and Python scripts that show you how you can replicate the same thing. And the way that they approach this problem is by not just storing the vectorized data into a vector data store, but also attaching a piece of context to that vector data when performing the storage, and that will help with the retrieval. And I'll show you what that looks like. When you have a chunk of text, meaning what you want to store in a database, being the company's revenue over a period of 3 months, contextualized chunk, that piece that I mentioned you add, is the piece that helps both those who are looking at this data from humans' perspective and AI agents, helps agents to understand contextual relevance of that chunk. So in this case, the chunk is from a file lane, it belongs to a specific report. The report was used to generate a certain amount, and then the revenue grew by a certain amount. So all of this information is used during the retrieval process. And this is how you can improve the accuracy of a traditional reg. You contextualize the chunk of data you store as a summary as it relates to that piece of chunk or content. And when performing retrieval, you use both the original chunk and contextualized chunk, meaning what you store and how it's relevant when performing the search. Implementation here is actually quite nice. The Anthropic team is very open, and so they've shared not only the methods but also the system prompts they've used. Here they use Claude 3 Haiku, which is a really great model for very affordable summarization. And in this case, they pass in the document of the data that they want to store as knowledge base, meaning the chunk. The entire document here. And then I'll tell you why that's useful. They store the most relevant chunk here as an XML data tag here. They're able to pass in the human chunk of relevant content. That can be, for example, company revenue data. That could be source code. It could be any piece of content here. And they guide the Haiku model in creating a summary of that chunk. But the summary is possible because they're able to pass in the entire document of what a developer would be storing on the vector database. So in this case, it's not just what they want to store. This is the traditional reg. In this case, here is the additional piece that is very important. You store the document as entire string here. You then compare the document with the chunk, and then you're giving a summary of the combination of the two. This is the contextual part. So if we scroll down here, we're going to see contextual pre-process, so they show you how it works. Again, just a recap of what I've described. You have contextual chunking of data. You run through a new language model the summarization step. This is what they call pre-processing, or essentially better data storage. You now have a contextualized piece along with the chunk. You go through the same process as before. You're asking the user to make a query. You do a lookup, but now the lookup includes not only the chunk but the contextual piece. If we scroll down here, they describe their methodology. They talk about the differences between standard and contextual in terms of performance. And then at the end, I think it's important to understand that everything they've shared with their strategy is open, and the source code is available for those who are curious on GitHub. And the performance is actually quite substantial. So when you combine both the pre-processing part that I described, then they do another additional step here for re-ranking, meaning sorting of the results. You get back a substantial reduction of failure rate. So in this case, a traditional method may give you 6% failure rate, and when you combine the contextual retrieval with the re-ranking, you've dropped it to about 2%. So that's 3%, or rather 3 times reduction. So this system is able to hallucinate 3 times less, or it's able to make 3 times less mistakes in the process of responding. And of course, this entire blog post is quite detailed. So if you have any additional questions on their implementation, definitely take a look. And as I mentioned, they do have a cookbook to guide developers or anyone who's interested to implement it. The second piece that I'll mention here is the MCP, which is an initiative led also by Anthropic team just shortly after the previous release. So back in the blog post for contextual retrieval, that was made on the September 19th, and MCP was published on November 25th. So 2 months roughly afterwards, the same team created a new protocol open source protocol called MCP, and I do have a video about that, so if you're interested, definitely check it out. MCP is another way to help agent developers and anyone who's interested to implement RAG into their pipelines. Now, MCP abstracts away the complexity of a RAG, and so developers not required to, for example, to build out their own vector stores or contextual RAG. They simply use MCP, Model Context Protocol, to allow their agent to connect to third-party data as a way to save time and save on development. And a couple things that I'll mention here that I think is quite important. So Jason Liu, the co-founder of Instructor, talks about RAGs, and he describes them, in this very in a very witty blog post here. He talks about how to build terrible, and of course he's making fun of the fact that you can make them systems better. Now, he doesn't describe the idea of contextual RAG in the way that Anthropic does, but he does talk about the idea of thinking about RAG systems as recommendation systems, which I think are quite useful here. Recommendation systems are another way to consider solving the problems of traditional RAGs. If you see them nothing more than answering your question based on criteria, then it helps you to build a better system. And last piece I'll mention here is what Jason attributes to be as the future of RAG. Of course, this is one way you can apply a RAG system, but nonetheless, he believes that RAGs are primarily used for report generation. And when you have a RAG and it's answering questions, it's essentially a Q&A system. And while that's able to help you when you're doing certain problems that involve being able to answer those questions, and just like MCP server is able to answer those questions for you, the value actually lies in the next step of a RAG, so taking action. And in this case, he describes generating reports. And of course, RAGs are just a more advanced version of search and retrieval. The biggest hurdle or limitation they're facing is the fact that they're limited by context window size. So MCP actually aims to really help with this. If you're using a model that has less token context window, then you can fall back on something like MCP to handle dealing with token count. But if you're dealing with a larger or more recent model, for example, if you have the newly released Gemini 2.0 Flash model, which is a model that has 1 million token count, this allows you to pass in a lot more data into the model and then have the model keep all of the contextual data in memory without relying on contextual retrieval. So it is sort of the difference between storing data in short-term memory and storing data in the long-term memory. Contextual retrieval or contextual RAG is storing data in a long-term memory because you're using a vector store. If you use a more powerful model like the Claude 3.5 Sonnet or Gemini 2.0, as I mentioned, that has bigger token window counts like 120,000 or a million tokens, you don't need to rely on contextual retrieval. And so my thoughts here is that you can use contextual RAGs. You can think of them as recommendation systems. They can help you to generate reports in the short term, but keep in mind that as language models improve, as the context window size improves, you will be able to pass in more data into whether it's a system prompt or the user prompt, and this will help you to overcome the problems that traditional RAG systems are facing. And so this is a technique that works in the short term because of the fact that the language models are limited in their ability to deal with context. As the models get better, I anticipate that we will see less contextual RAG systems, but nonetheless, the Anthropic has MCP, and it's an open source initiative that helps you to essentially implement a RAG pipeline without worrying about the complexities of managing vector stores or dealing with chunks. So if you want to see more videos like this, please let me know, and I'll be happy to contextualize my videos for you. If you need assistance in implementing contextual RAG, if you need to get started with MCP or even implement recommendation systems as RAG workflows, or even report generation systems as Jason mentioned, feel free to reach out to me, and we'll be happy to get you up to speed. And beyond that, I look forward to creating the next video for you. Until next time.